Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Teacher Hayati. So for today we are going to learn about the mechanism of the heartbeat. Learning standard. At the end of the lesson, you will be able to describe the human heartbeat mechanism that involve the sinoatrial node or a pacemaker, atrioventricular node, a bundle of his, and also Purkinje fibers. Mechanism of the heartbeat. The heartbeat is made up of the cardiac muscles. They are intersect and are connected with one another. So according to this diagram, okay, you can see that the cardiac muscle, they are intersect from one cells with another cells so that it will allow the electrical impulses to spread rapidly through the heart and at the same time stimulate the cardiac muscle cells to contract simultaneously and uniformly. Mechanism of the heartbeat. Cardiac muscles are myogenic. So, what is myogenic? Myogenics means the heart contracts and relaxes without receiving any impulse signals from the nervous system. The pumping of the heart. The contraction of the heart is initiated and coordinated by the pacemaker. And what is pacemaker? Pacemaker is a group of specific heart muscle cells that initiates the rate of heart contraction and is located at the right atrium wall. Let me introduce you the cardiac conduction system. The cardiac conduction system includes the first one, a sinoatrial node or a pacemaker, and which is also known as a SA node. Okay, this is the location of the SA node. Second is the atrioventricular node or also known as AV node, and this is location of the AV node at the bottom of the atrium. A bundle of his, okay, this is a bundle of his, they are connected with the AV node, and then the bundle of his will be branches into a bundle branches, and then connected to the last part of the system, which is the Purkinje fibers along the ventricles. The heartbeat originates in the cardiac muscles in the pacemaker. So again, we have to know that a pacemaker is a sinoatrial node that also known as SA node. It is called pacemaker because each wave of excitation begins here and also it acts as a stimulus for the next wave of excitation. The sequence of events for pumping of the heart. The first event, the sinoatrial node or SA node will generate the electrical impulses. SA node generates wave of the excitation about 70 to 80 times per minute. It will initiate and coordinate contraction of the heart. And again, SA node is the cluster of specialized muscle cells that produce spontaneous electrical signals at regular rate, and it is located at the wall of the right atrium near the entrance of vena cava, superior vena cava. Though this is a superior vena cava, so the SA node located at the entrance, near the entrance of the superior vena cava. Second event, electrical impulses spread rapidly in both atria. After it is generated by the SA node, then the electrical impulses will be spread rapidly in both atria, causing the atria to contract simultaneously. And the contraction of the atria helps to pump the blood into the ventricles. When the atria contract, it will produce a pressure, higher pressure that will push the blood flowing into the respective ventricles. And then, even the third event, the electrical impulses reach the atrioventricular node. This is the atrioventricular node. The electrical impulses spread through the bundle of His and the Purkinje fibers up to the apex of the heart. So the bundle of His will be branches into the bundle branches, okay, both sides, and then up to the Purkinje fibers, okay, and to the apex of the heart. Okay, tissue of AV node are similar to SA node. Okay, so again, you have to know that the AV node located at the base of the right atrium, still in the right atrium. Just now, SA node located at the near to the entrance of the superior vena cava. Okay, while the AV node located at the base of the right atrium. Function of the AV node is to connect the atria and the ventricles electrically. And bundle of His will provide the only route for the transmission of the waves of excitation from the atria to the ventricles. Bundle of His. So what is bundle of His? Bundle of His consists of modified cardiac fibers that do not contract. So fibers of the bundle of His divide into right and left bundle branches. So this is a bundle of His. They are connected directly with the AV node, and it will be divided into left and right bundle branches. And then the bundle branches will run to the tip of the ventricles. They will run to the tip of the ventricles and then spread throughout the ventricle as a Purkinje fiber. So when from the tip of the ventricles, now it becomes a Purkinje fibers. Event number 4, the electrical impulses spread from the apex of the heart to the whole ventricle wall. From the apex of the heart to the whole ventricle wall. As a result, the ventricles contract to pump the blood out to the lungs and the body. Alright? Okay, so the left ventricle, the left ventricle will pump the blood to the whole body, while the right ventricles will pump the blood to the lung. Okay. One question. During exercise, the heart pumps out a greater volume of the blood per minute than when the body is at rest. List 2 ways in which of the heart can increase the volume of the blood pumped out. Can you answer that? Okay, good. So the answer is by increase the heartbeat rate and by when each beat becomes stronger. So this will causes the heart to pump out a greater volume of the blood per minute. Okay, cardiac cycle. So this is the process of the cardiac cycle. You can see, okay, we have a cardiac diastole. We have a few terms here. Okay, diastole and systole. Cardiac diastole, atrial systole, ventricular diastole, atrial diastole, ventricular systole. Okay, so the common name here is the diastole and systole. Okay, and you have to notice that atrial means atrium and ventricular means ventricle. So we will go one by one. Okay, the step one by one. Again, the sequence of events starting from the cardiac diastole. Cardiac diastole means the atria and the ventricles are relaxed. During this event, the blood returning to the heart under low pressure in the veins and entering the atrium, left atrium and the right atrium. The left atrium will receive the blood from the lungs and the right atrium will receive the blood from the whole body. Okay, second event is the atrial systole. Atrial systole means the atria contract and the ventricle relax. During this event, the two atria, left atria and the right atrium will be contract simultaneously. At the same time, the tricuspid valve and bicuspid valve will open to allow the blood to flow to the respective ventricle, left ventricle and the right ventricle. Okay, so this is tricuspid valve and this is bicuspid valve. And note here, the atria contract, it will force the blood into the ventricles. So the contraction of the atrium that causes the blood to be forced to the ventricles. And for the same times also, semilunar valve will close, which is the aortic valve and pulmonary valve. The third event, ventricular systole, it means that the ventricles contract and for the same time the atria will relax. During this event, the bicuspid and the tricuspid valve will close and the semilunar valve will open. Note, the ventricles contract, forcing the blood into the aorta and the pulmonary artery. So the blood in the right ventricle will be flow into the pulmonary artery, while the blood in the left ventricle will be flow to the aorta. During this event, the bicuspid and tricuspid valve will close to prevent the backflow of the blood to the atrium. And the fourth event, ventricular diastole, which is the ventricle will relax. When the ventricle relax, the high pressure developed in the aorta and the pulmonary artery tends to force some blood back towards the ventricle. Thus, the semilunar valve of the aorta and pulmonary artery will close. Okay, now let us use a virtual reality application in viatip.com to observe how the transmission of impulses are transmitted throughout the heart. Do you know that the human heart beats more than 10,000 times a day? The sequence of events that occur to complete one beat is called cardiac cycle. At the beginning of the cardiac cycle, all the four chambers of the heart will relax, and this condition known as cardiac diastole or joint diastole. During this condition, the superior vena cava and inferior vena cava carry deoxygenated blood from the lower part and the upper part of the body in the right atrium of the heart. Superior vena cava will transport the blood from the upper part of the body, while the inferior vena cava will transport the blood from the lower part of the body to the right atrium. And the type of the blood is the deoxygenated blood. At the same time, oxygenated blood from the lungs will enter the left atrium. So this is left atrium. The oxygenated blood from the lungs will enter the left atrium through pulmonary vein. When both atria are filled with the blood, the electrical impulses generated by the SA node. Okay, so this is the location of SA node. Okay, near to the entrance of the superior vena cava. The electrical impulses then spread across the left and the right atrium and finally reach the AV node. Okay, this is AV node at the base of the right atrium. These impulses causes both atria to contract, and this condition called as atrial systole. So both atria will contract. Okay, this is called as atrial systole. The contraction of the both atria causes the opening of the atrioventricular valve, which is a tricuspid and bicuspid valve. This allows the blood from the atrium to flow to the ventricles respectively. At the same time, semilunar valve, which is pulmonary valve, and also aortic valve will remain closed. The electrical impulses then travel from AV node to the bundle of His and finally to the Purkinje fibers. This causes the ventricular contraction that also known as a ventricle systole. Internal pressure of the ventricle increases, causes the atrioventricular valve to close to prevent the backflow of the blood from the ventricles to the atria. So when the ventricle contract, when the ventricle contract, both tricuspid valve and the bicuspid valve will close to prevent the backflow of the blood from ventricle to the atrium. Closing of the atrioventricular valve producing the first heart sound, which is loop. For the same time, semilunar valve will open to allow the blood flow to the aorta and to the pulmonary artery. The release of the blood from the ventricles causes the ventricle to relax or ventricle diastole. Okay, so when the blood flow to the artery pulmonary and the aorta, now the ventricle will be relaxed or ventricle diastole. During ventricular diastole, the blood in the aorta and pulmonary artery move back to the semilunar valve, causing them to close. The closing of the semilunar valve producing the second heart sound, which is doop. And the closing of the semilunar valve also reduces the pressure in ventricles. On the other hand, the internal pressure of the atria increases simultaneously, indicating the beginning of another cycle. Okay, so we're done on the animation of the cardiac cycle. So we are going to the assessment. Okay, you have to follow the instruction to perform the activity and earn points. Okay, you can only try multiple times, but points are only awarded if you answer correctly on the first try. Okay, let us do together, okay? Okay, we click bisect to view the cross section of the heart. Okay, first question, identify the present stage of the cardiac cycle. Okay, observe the condition of the heart. All the four chambers of the heart in the relaxed stage. So it is known as cardiac diastole, or also known as joint diastole. Okay, good, correct. Click on the chamber where the oxygenated blood enters from the lungs. Anyone? Okay, good. The left atrium. You get a second score. Okay, third question. Click the chamber where the deoxygenated blood enters from the rest of the body. Which chamber? Yes, correct. The right atrium. Okay, you get the third score. Next question. Identify the next stage of the cardiac cycle after the atria fill with the blood. What is the next stage of cardiac cycle? When the atria fill with the blood, the atria will contract, which is, okay, correct, the atrial systole. You get your fourth score. Next, identify and click on the valve that open during atrial systole. When the atrial contract or atrial systole, which valve will open? Good. The atrioventricular valve, which is tricuspid and bicuspid valve. Okay, you already get 6 scores. Now that the ventricles are filled with the blood, what is the next step in the cardiac cycle? Okay, now the blood is already filled the ventricles. So what is the next cycle? Amazing. The ventricle will contract, which is ventricular systole. Okay, you already get your 7 score. Next question. Ventricular systole leads to the opening of the semilunar valve. Click on the valve to select them. Okay, which one is the semilunar valve? At the opening of the aorta and also at the opening of the pulmonary artery. Okay, okay, wrongly click. Alright, so next question. Click on the vessels that will carry the oxygenated blood to all parts of the body. What? Yeah, the biggest artery, which is aorta. Okay, click on the vessels that will carry the deoxygenated blood to the lungs. Okay, which one? Yeah, correct. The deoxygenated blood from the right ventricle will be carried to the lungs through pulmonary artery. Well done. Okay, you have to complete this activity and here is your score. Okay, you get 90%. Alright? Okay, congratulations to all of you. Okay, we are going to the next quiz, which is a nodal tissues. Follow the instruction to perform the activity and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Okay? Okay, locate the SA node on the heart and then click on it. Where is SA node? Correct. At the right atrium and near to the superior vena cava. Click on the next destination of the electrical impulses. From SA node, the electrical impulses will be transmitted or transported to the, yes, AV node. Correct. What is the name of this node? Papillary muscles, Purkinje fiber chordae tendinae, or AV node. This is called as AV node. Identify and click on the bundle of his. That's true. This is a bundle of his. Okay, wrongly click. Alright, then click to set the final destination of the impulses. Okay, to the Purkinje fibers. Click on the appropriate name of this area. Okay, again, this is Purkinje fibers. So that is correct. Okay, well done everyone. You have completed the assessment and here is your score, 80%. Congratulations. Sound of the heart. During the heart pumping, the loop-doop sound can be heard. The loop-doop sound is the closing sounds of the heart valve. Sounds of the heartbeat come from the turbulence in the blood flow causes the valve closure. The two normal heart sounds which each heartbeat is loop doop. The first heart sounds loop occurs when atrioventricular valve closed, while the second heart sound loop occurs when the semilunar valve closed. Okay, now let us watch the 360-degree virtual reality animation inside a beating heart. Okay, so if you can identify, okay, this is the atrioventricular valve, which is tricuspid valve, while this is the semilunar valve, which is pulmonary valve. Look at the closing and the opening of both valves. When the tricuspid valve closes, the semilunar valve will open, and vice versa. When the tricuspid valve opens, the semilunar valve will close. The closing of the atrioventricular valve, which is a bicuspid valve and tricuspid valve, will produce the loop sound, while the closing of the semilunar valve will produce the doop sound. That's why the heart sound is loop doop, and loop doop. Okay, this video will bring us to travel through the human heart using the virtual reality. So the blood in the left atrium will travel through the bicuspid valve into the left ventricle. So this is the left ventricle, and then the blood will flow through the aortic valve. Okay, so this is bicuspid valve, and this is aortic valve. The blood will flow out through the aortic valve to the aorta to be transported to all over the body. Okay, thank you everyone. That's it for today. Until we meet again. Thank you. Bye.